Hi everyone, welcome to this lecture. So in this lecture, we are going to learn another important data preprocessing technique that is known as data standardization. So the question is when we need a data standardization and how it is different from data normalization and min-max scaling. So basically we use data standardization when the units are totally different and incomparable. So what is meant by the totally different unit? Suppose I have a data and I have two columns in the data. In the first column, I have the quantity which is known as time. So I have a data about the information of time. So the unit is second. On the other hand, or in the second column, I have the value of voltage. So I have measured voltage. So the unit is volt. So in that case, we have totally different units. That is a unit of time in the first column and the unit of volt in the second column. In that case, there will be a difference in the magnitude of data as well because volt is different from the time. In that case, data standardization is better than performing data normalization and min-max scaling. The other situation may be that you have a same kind of unit but with different magnitude and different power. Now suppose I have a data with three columns. The first column is about the length of an object. So the unit of length is meter. The second column is about the area of the object. So the unit of area is meter square. And the third column is about the volume of the object. So the unit of volume is meter cube. In that case, I have a common unit with meter, but with different magnitude. That is meter, meter square, and meter cube. In that case, it is also better to perform data standardization than min-max scaling so that our features becomes compatible. So what are the important steps in data standardization? So the first step is that we have to calculate the mean of the data. So this is the important equation of the data standardization. We have to calculate the mean of the data. Then we have to calculate the standard deviation of the data. Then we will subtract the mean from each sample of the data, and then we will divide this difference with the standard deviation. So these are the important steps of the data standardization. So this is the data standardization. So in data standardization, we also assume that the data is like a curve bell or this is like a Gaussian distribution. So this is the mean of the distribution, which is the central value of the distribution, and the standard deviation represent the spread of the distribution. So the first step is to calculate the mean. The second step is to calculate the standard deviation and then subtract the mean from each sample and then divide the difference with the standard deviation. So here is the example of data standardization. This is our original data, and we can see that every feature is of different magnitude. When we perform data standardization, we get the features like this, or we get the data like this. So we can see that in the first column, the minimum value is minus 1.41 and the maximum is 1.41 with the plus sign. In the second column, the minimum value is minus 1.4896 and the maximum is 1.40. In the third column, the minimum value is minus 1.35 and the maximum is plus 1.29. So we can see that in all these three columns, the minimum and maximum values are different, but they are close to each other, and there is no column which is dominating, that is whose magnitude is very high as compared to other. So in this lecture, we learned about the data standardization. We learned that data standardization is a better technique than data normalization and min-max scaling when we have different and incomparable units, especially the units like time and volt and the units like meter, meter square, and meter cube. So I hope you understood the importance of data standardization with this lecture. Thanks for listening, and I will see you in the next lecture.